Hey everyone, Mrs. Spatola here. Today's lesson is going to be a bit of a review, but before we get going with that, let's take a look at our last assignment. Here are the answers to number 5. Amy's creating goodie bags for her birthday party, and she has 10 candy bars and 25 balloons and 40 Jolly Ranchers. What's the greatest number of equal goodie bags she can make using all of the items? As we spoke in our last video, when you're reading these type of problems, you want to look at the key words. The greatest number. There are clue words here that are going to give you a hint of what they're looking for. In this particular case, you have 3 numbers, and what they're looking to do is make equal goodie bags, and she wants to use all of the items spread across the goodie bags. Well, what you have to do is find the GCF for each number, and then divide each number by the GCF. One little trick, though, just wanted to bring this to your attention in case you haven't noticed it already. One thing you might notice is that when you find the GCF in the T-charts, if you look at the number on the opposite side of whatever the GCF is, that is going to be the number that's going to answer that question for each category. So for example, for number 5, the GCF is 5. And then if you notice each category for the candy bars, how many candy bars are going to be in each bag? Well, if you have 5 goodie bags and there's 10 candy bars, you would just simply divide. And then you do that for the other 2. Take a look, pause the video, make sure you understand how this works. And if you don't, please make sure you ask some questions. Let's take a look at the answer for number 6. And number 6 is a similar format, and there are the answers for number 6. Let's take a look and see what's on today's agenda. For our Unit 4 study guide for factors, we're going to review a couple of the concepts that we've been working on in this unit. The first thing is prime numbers, a number that has exactly 2 factors, 1 and the number itself. The number 2 is the only even prime number. So if you look at this chart that's given here, those are the prime numbers. So what you're going to do for number 1 is list the prime numbers to 100. Moving on, composite numbers. A composite number is a number that has more than 2 factors or 3 or more. Prime versus composite, again, prime only has 2 factors. Composite has more than 2 factors. I like to look at composite numbers as 3 or more. Now, divisibility rules. This was a topic that we did previously. So what you're going to do, very important in this unit, when you're looking at number theory and prime and composite numbers. So again, just to review some of the previous concepts, a number is divisible by 2 if the last digit is even. And we talked about even numbers being 0, 2, 4, 6, or 8. The last digit is where it ends. Okay, so you want to look. In this chart, this is good to go through. It goes through the divisible numbers and the ones that are not divisible. So it shows you an example of what a number divisible by one number should look like, and then if there's another one that is not divisible. Here's a popular one, and you may see this really soon. A number is divisible by 3 if the sum of the digits is divisible by 3. Okay, so for 315, this is review again. 3 plus 1 plus 5 is 9. Is 3 divisible by 9? Absolutely. So that's how you know if a number is divisible by 3. Also, you have a calculator. Please use your calculator. I cannot express this enough. Okay, if a number is divisible by 4, if the last 2 digits form a number divisible by 4, you need to know your multiplication tables or simply use your calculator. A number is divisible by 5 if the last digit is a 0 or a 5. A number is divisible by 6, love this one, if the number is divisible by both 2 and 3. They have to meet both of those criteria. So the number has to be an even number, obviously, and that number has to be divisible by 3. Also, the sum of the digits. These are examples here for divisible. A number is divisible by 9 if the sum of the digits is divisible by 9, very similar to the rule of 3. And a number is divisible by 10 if the last digit is a 0. All right, so now for numbers 12 through 14, you're going to circle the answers using the divisibility rules. Let's move on. On this page here, it talks about more about divisibility rules. Let's move forward. Prime factorization and factor trees, the process of representing a composite number as a product of prime numbers. So here's how it goes. In this particular case here, the numbers, just ignore the numbers. It really should be 1, 2, 3, 4. These are the steps. So the first thing you want to do is pick any set of factors for that number, which means what two numbers multiply out to the first number. Keep factoring the numbers until only numbers left are prime numbers. Circle and list all the prime numbers and list the numbers in order from least to greatest, and write your answer in exponential form or exponent form. Again, let's take a look at a quick example. So for the number 30, watch what happens. I multiply it by, I pick 5 and 6. 5 is a prime number, circle it. 6 can still be split up because that is still a composite number, but I know that 2 times 3 is those are factors of 6. So my final answer for 30 would be 5 times 2 times 3, but you're supposed to put them in order from least to greatest. If you don't, we won't hold that against you. So this is 2 times 3 times 5, and that is the prime factorization for the number 30. Now, if you look at 72, look at all the circled numbers. When they ask you to write it in exponent form, watch, 72 would be like this. 2 times 2 times 2 times 3 times 3. Now, you can also pop this in your calculator to check it. So this would be in exponent form. What would that look like? Yeah, 2 to the third power times 3 to the second power. Exactly. Let's take a look. More factoring if we continue on. If we look here, factoring numbers using a T-chart, everybody's favorite thing. You need to make sure you start with the number 1 itself. Factoring numbers in a T-chart, the process of using a chart to identify the factors of a number. Always begin with 1 and the number itself and go through all the numbers within. So for example, for 16, if you take a look here for 16, we start with 1 times 16 and then we go, does 2 go in? Yes, it does. 2 times 8. Does 3 go in? No. Does 4? Yes. 4 times 4. When you have a double, you're done. Same thing with 24. You start with 1 times 24, 2 times 12, 3 times 8, 4 times 6. Lastly, for 15, 1 times 15, 3 times 5, and you're good to go. Let's look at the last concept and topic for the review for today. Greatest common factor. With greatest common factor, you are looking for the greatest number or factor that two numbers have in common. And there are 2 methods to find the GCF, using the T-chart and using prime factorization. The GCF will be used to simplify fraction and to find the least common denominator when adding and subtracting fractions with unlike denominators. Do not worry about using the prime factorization method. That is not going to be something that you're going to be held responsible for. So you definitely want to make sure that you use the T-charts. And that's what you're going to complete today. This is Mrs. Spatola wishing you a great day. And remember, always, always be kind.